What is the likely bond type in a binary compound formed between two elements with identical electronegativities? And then we have like a multiple choice here, A through D. So with this, would the compound feature polar covalent bonds? Would the bond be ionic due to transfer of electrons? Would the bond be nonpolar covalent due to equal electron sharing? Or does the bond involve delocalized metallic electrons? Okay, so we're talking about a specific bond. They did say that it's a binary compound. Binary just means that you have two elements. And it could be two of the same, it could be two different, so it doesn't really matter here. They do say that, okay, yeah, we have two elements, so binary and two elements, that checks out. And they're just saying that each element has identical electronegativity. So let's just pretend that it's maybe the same element, right? If you have identical electronegativities, chances are that the elements are the same. Doesn't have to be the case, but we try to make it as easy as possible. So elements are the same. So, I don't know, pick your choice, right? Give me two elements that are the same that can bond. Now, normally when you have two of the same elements that bond, it is going to be a covalent bond because two metals can never, two positive charges coming together can't really form a bond. Like Na can't form a bond, right? Because if you have sodium, you have to have a nonmetal as well. So, I don't know, let's pick H and H, right? We'll go way simple. Hydrogen and hydrogen. And we know that hydrogen and hydrogen, they're going to have a bond, right? And hydrogen is a nonmetal. And so is the other hydrogen. Now, the type of bonding that forms when you have two nonmetals come together, that's covalent bond. Which means that these electrons are being shared. So if I strip this line away and we actually see what's going on with the bond, there's two electrons in this vicinity. Now the question is, are the electrons going to be equally spaced out? Or is one hydrogen going to be greedy and pull it towards themselves, right? But they do say that they have identical electronegativities. Electronegativity is the property in which an atom has an attraction toward electrons, I'm just going to put E minus, in a bond. So that's the pulling, right? And if you can pull the electrons more closely to an atom, the electronegativities have to be different. But they said that these are identical. So it doesn't really matter what number you give, right? Because we're just talking theory. But if this hydrogen, usually hydrogen has an electronegativity of 2.2 or 2.1, depending on, the textbook that you're using, this one would have to be identical. And to make it even simpler, right, you could think about it in terms of a game, right? If you're watching a game, right, whether it be baseball, soccer, football or whatever, if the score is 2-2, did anyone win? No. Did anyone lose? No. It's a tie. And in terms of chemistry, a tie means that you have equal sharing. If nobody won, they have to split it equally. So we know that this is a covalent bond, and since they have identical electronegativity, there has to be some type of equal sharing. Now, just know that the equal sharing means that you have no pull, right? No one element is pulling the electrons towards itself. And if you have no pull, you think of the P word in chemistry, polarity, right? So if you have no pull, it's a non-polar. Polar, whenever you see the word polar, you think of pulling the electrons towards one atom. But since it's all equal sharing, this would be a non-polar bond. So for letter A, the compound features polar covalent bonding? No, this is equal sharing. What we should have. Polar means that there's unequal. And that would mean that the electronegativities would be different. So this one is not the correct answer. The bonding is ionic due to a transfer of electrons. Ionic bonds are between a metal and a nonmetal, and just know that ionic bonds will never, ever, ever have identical electronegativities. If you're classifying a bond as being ionic, just know that that electronegativity differences, aka the difference between these two values, has to be greater than 1.8. So if this was 2, the other one has to be at least 3.8, because 3.8 minus 2 is 1.8. But now we come down to C, and we see that it says the bond is nonpolar covalent. That's correct. And it's because of that equal sharing. So we found the correct answer. And as I boss this off, we look at D, right? D says that the bond involves delocalized metallic electrons. Just know that if you have a metallic bond, you only have a single metal. So it would be basically a bunch of irons just chilling, a bunch of coppers just chilling. It wouldn't be a binary compound. So that one is automatically out. And that's it. What'd you think? I hope this helped. Let me know in the comments. Thank you so much for viewing the video. Check our website out, glazersguide.com. The link is in the description. Tons of questions just like this to help you guys out with this topic. We have a big overall review topic video for all the topics in chemistry. So grab a drink, grab your snacks, and let's learn together. All right, it'll be fun. We'll get to hang out. We get to learn. What's more better than that, right? Yeah. We'll pretend nothing, right? We'll pretend nothing. But anyway, thanks for hanging out. I'll talk to you guys later, and hopefully I'll see you on the website. All right? Bye-bye.
For more practice and for more fun, go to glazersguide.com.
And for more practice and for more fun, come on, go to glazersguide.com.